Let's start solving question 8 in this video. So we have the city government that wants to reduce littering. So there's a $100 fine for littering and there's a 10% probability of being caught if you litter. Now, there are two different policies to think about. Now, it can increase the number of police officers who monitor littering, and in that case the probability of being caught is going to be 20% instead of 10%. Or the second policy is that it can keep the monitoring level the same, but the fine might increase from $100 to $200. Okay, the expected cost of littering is the same. Now the question is, if the people who litter are risk averse, which policy would lead to a larger reduction in littering? And what if the litterers are risk loving? What's going to be the result over there? So first of all, the highlight of the question. The expected value of the fine under both cases is $20. In the first case, we have 20% probability of paying $100 for being caught of littering. In the second case, we have 10% probability to pay $200. In either way, in expectation, we might pay $20. Now, the utility depends on a certain benefit from littering, like it's very convenient to just throw on the floor right away, and the income that we have. Now, in the first case, what do we have in the first case? Let's call that A. We have a risk-neutral individual, right? We have risk-neutral behavior. If we're risk-neutral, what does it affect us if we are charged the first policy or the second? Well, in either case, we're going to pay $20. So the behavior is going to be the same. It won't make us litter less or litter more. What's the intuition here? The reason we want to look at the behavior of the consumer is because if the consumer has a lower expected utility from a certain policy, then he will avoid it. He will not want to litter because he is hurt, right? So in this case, the expected utility is the same under both policies. So none of them gives an incentive to reduce littering. So none of them gives incentive. None of them gives incentive to reduce littering. Incentive to reduce the littering. Okay, that's the simple case when we are risk neutral. But the other question is, what if we are risk loving? Okay, so if we have a certain concave utility function. Well, concave utility function should be actually risk averse, not risk loving. But anyway, maybe it's a typo. So we should have a concave utility function. How does a concave utility function look like? Well, graphically we're gonna draw this in the next video. But for now, when we have the other scenario, what is going to be the expected utility from every policy? Let's see. The expected utility from the first policy, right? Let's call that I. Well, the expected utility from the first policy would be that there is a 20% probability of being caught. So we would have a probability of 0.2 that we are going to be caught, and in that case our utility is going to depend on the benefit that we have from littering and the income that we are left with, and the income would be the money that we have at our disposal minus the $100 that we have to pay for the fine, right? And with the remaining 80% probability, we would have the utility that depends on the benefit of littering and the income that we keep, because we would not pay the fine. This is the probability of not being caught. Let's just write the highlight underneath to know what we're following. This is the probability of being caught, and this is the probability of not being caught. So not caught. Hope this makes sense. With the same logic, let's do the expected utility of the second policy. What would be the expected utility of the second policy over here? Well, let's see. Under the second policy, we would have 10% probability of being caught. So we would have 0.1 multiplied with the utility that we would get based on the benefit of littering, of throwing on the floor, and the income that we are left with. And the income in that case would be y minus 200, because under the second policy, let's just go back up here real quick, under the second policy the fine would cost $200. So the net income left in our pockets would be whatever money that we have minus $200. And the remaining probability, which is 90%, so plus 0.9, we would get utility from the benefit of littering and the income that we keep, because in this case we keep all the money. We would not be caught. Again, let's write the highlights of what's going on here. This is the probability of being caught versus the probability of not being caught. Okay, now if any of these expected utilities is lower, it means that policy makes it less attractive for the person to throw trash on the floor, to litter. So it means that it will make the person not litter, reduce the littering. It will be effective. So we want to know which one of these expected utilities is going to be lower, and we'll just write this inequality that we must solve, and in the next video we'll keep solving, because this is not a very simple question. Like, it requires a bit of math and a bit of you know, the graph is going to help as well, but it's going to be doable in the end. So we're comparing the first policy versus the second. So we're comparing these two expressions. We would have 0.2 multiplied with the utility of that benefit and y minus 100 plus 0.8 multiplied with the utility of b and y. And on the other side we have the second expression, this one over here. That would be 0.1 times the utility of b y minus 200 plus 0.9, let me go to the right, 0.9 multiplied with the utility of b and y. In the next video we'll see how this works out also with the graph, and it's all gonna make sense.